Now on to our seventh and final part of our analysis of our truss structure. We're going to focus on this joint just here, and then we'll have a look at that joint just to tie up some loose ends. This joint here, very nice and simple. We have 1740 newtons in tension. So in tension means it's pulling away from that joint. That's got a vertical component. This one doesn't. The only other three members touching that is this, this, and this. If that's vertical, then that's got to have the vertical component, which has to completely counteract that one. So pulling away, this one has got to be pushing it back up. So that one's going to be in compression, and it's got to have the same value of that so that the vertical components equate there to stop that from moving. So we know that that one is going to have to be 1740 newtons in tension. So that's all of our members in compression. Sorry. So that's all of our members accounted for. Let's just draw this one. Just so that's in compression. So it's pushing the top joint away. It's pushing the bottom joint away. If you do a very quick analysis, 1740 is pushing down here. This force is pushing back up at 1333. If we look at the vertical component there, then we have 1740 sine of 50 degrees, and 1740 of sine of 50 is 1332.9 roughly. Let's round that up. That's going to equal 1333 acting down, which is what you expect vertically. That's not moving, so that works quite well. Horizontally, we have 1121 newtons in tension, so pulling that joint away. This one's got to be pushing back. The horizontal component has got to be pushing back at that same amount. So that's 1740 cos of 50 degrees. If you do that, we get an answer of 1118.45. Now that doesn't round off exactly to 1121, but don't forget we've done a lot of rounding up to this point now. So this one worked quite well. I think we have just too many rounding errors by rounding too early, so that's why that doesn't quite balance out. But obviously in real life it must bounce up. So that's the end of our truss analysis. Nice and simple.